Hi, welcome to the application security domain video. This domain is focused on cloud application security, which covers the secure software development cycle with the new methods of DevSecOps, CI/CD. There are 6 questions expected in the exam from this domain. This video is certainly going to help you to prepare for CCSK exam in the lesser effort and time. Watch till the end to avoid any misconception or confusion. If you are watching my videos for the first time, please subscribe to the channel for the regular video updates. So before we go into the application security, let's try to understand what are the opportunities in the cloud in terms of the security. The day by day, the application security is evolving at an incredible rapid pace as the practices of the application development, which continues to progress and embrace new processes, patterns, and technologies. This opportunity offers the guidance for cloud teams who want to securely build and deploy the applications. Um, how application security offers differs in the cloud computing. Review the secure software development basics and how those change in the cloud, leveraging the cloud capabilities for more secure cloud applications. So these are the things which will certainly gives an opportunity to guide to the development teams. Of course, when we talk about the higher baseline security, this means the cloud providers, especially major information infrastructure as a service provider and platform as a service providers, maintains higher baseline security. In the cloud environment, the major baseline security failures that completely undermine the trust that a public cloud provider needs in order to maintain the relationship with the customer base. Of course, the cloud providers are also subject to a wider range of security requirements in order to meet all the regulatory and industry compliance baselines need to attract the customers from the verticals. And the responsiveness, in terms of the responsiveness, APIs and the automation provides the extensive flexibility to build more responsive security programs. Certainly at the lower cost than the traditional infrastructure. For example, changing the firewall rules or deploying the new server with the updated code can be handled with the few API calls or through the automation or the automated APIs. It is not possible in the traditional infrastructure. Isolated environment, the cloud applications can also leverage the virtual network and the other structures, including the platform as a service for hyper segregated environment. For example, it is possible at no additional cost to deploy multiple application stack on the entire separate virtual networks, eliminating the ability for an attacker to use one compromised application to attack others. Um, Independent virtual machines, the security is further enhanced by the use of microservices architecture, since the cloud doesn't require the consumer to optimize the use of physical servers, a requirement that often result in the deploying multiple applications, components, and services on a single system. Developers can also instead deploy more small virtual machines, each dedicated to the function or the service. Of course, this reduces the attack surface of the individual virtual machine and supports more granular security control. Elasticity enables the greater use of immutable infrastructure. When using elasticity tools like auto scale groups, each production system is launched dynamically based on a baseline image and may be automatically deprovisioned without the human interaction. DevOps, it is a very important topic. DevOps is a new application development methodology and philosophy focused on the automation of the application development and the deployment. So in cloud, it is all integrated infrastructure. When it comes to the DevOps, the development cycle will go through the same DevOps infrastructure, and that will lend your code, your developed code, into the production environment. unified interface. A unified interface for the infrastructure and application services provides a more comprehensive view and better management compared to the traditional systems. And the devices like load balancers, servers, network devices, firewalls, ACLs, these are often managed by the different groups. This creates the opportunity to reduce the security failures due to the lack of communication or the full stack, because now we have a unified interface, and this is managed by one single team who understand the whole environment of that infrastructure from the development to the production. So the challenges in the cloud, of course, the opportunities comes with some other challenges. We have certain challenges here: limited detailed visibility in the cloud, in terms of the availability of monitoring and logging when it is impacted, required new approaches to gather the security related data, increased application scope, when the application scope is increased towards the management plane and metastructure application security, that directly affects the security of any application associated with that cloud account. Changing the threat modules. In terms of the threat models, the relationship between the cloud provider and the shared security model will need to be included in the threat model. It keep on changing on the different features and different deployment models when it comes to the cloud. Reduced transparency, there may be less transparency as to what is ongoing within the application. For example, you rarely know the entire set of security controls for an external PaaS services integrated with your application. Secure software development lifecycle, we also call it as SDLC. Um, so there are different aspects here. Uh, One is the secure design and development, secure deployment, and secure operations. The secure software development lifecycle is how cloud computing affect the application security from design to deployment. Um, the secure design and the development from training and the developing organization wide standards to actually writing and testing the code. The secure deployment, it is the security and testing activities when moving the code from isolated development environment into the production. Secure operations, securing and maintaining the production applications, including the external defenses such as WAF, Web Application Firewall, and ongoing vulnerability assessment. So secure design and development, there are different phases here when especially it starts from the training because we identify a team, and as part of that team, the team should be able to be able to perform the secure coding, writing the security test, and platform training. So it could be anything related to your development environment, or anything the technology that you are using in your development. So everything from the training point of view, it has to be covered for the team. It includes the development, operations, and security that all receives the additional training on the cloud security. Definition, it is we need to define the coding standard, code standard, security functional requirement for that system. Uh, the cloud user, of course, determines the approved architecture or the features for the provider, security standards, and the other requirements. Also, the cloud user determines the approved architecture and the features. In terms of design, when it comes to the design, it focuses on the threat modeling and the secure design. So in the exam, you may find some questions like what is the exact phase when we should perform the threat modeling in the SSDLC. So there may be questions when should we define the coding standard, in the SSDLC phases, or when should we perform the manual code review, in which phase it should happen. Just like in the development phase, it should be code review, unit testing, static analysis, dynamic analysis. So there are two concepts here. One is SAST, which is static application security testing in the development phase, and another is DAST, which is dynamic application security testing. So this happens during the development, and of course, the DAST can be done in the test phase as well. So in the test phase, we perform the vulnerability assessment, the dynamic analysis, and the functional test. Secure development deployment, the code review, it is a manual activity that is not necessarily integrated into the automated testing. But yes, the CI/CD pipeline might impose a manual gate, especially the special attention for the critical areas. For example, the areas where you are writing the code for the least privilege or authentication or kind of encryption. So these are the areas which requires the manual code review, and even in the automated CI/CD or in DevSecOps or DevOps, you may need to induce the manual gate to review the code. Unit testing, regression testing, and functional testing, these are kind of can be integrated with the security testing as part of the development cycle. SAST and DAST. SAST is a kind of the static application code analysis. This has to happen um, during the development, because it requires performing the code review using a tool and to identify the vulnerabilities in that code. And once the code is compiled, then the DAST is performed after the compilation when it is in the runtime. So DAST can only be performed in the runtime. Impacts in the cloud. So there are different impacts in the cloud on different activities. For example, impact on the vulnerability assessment. It is primarily this can easily be integrated with CI/CD pipeline. Accesses the containers, images before deployment, and run test against the entire infrastructure using infrastructure as a code. Um, Impact on the pen test cannot be performed without the permission, because in the multi-tenant environment you need to you have the other tenants as well, and you need to take the permission from the provider that you need to perform the pen test, and um, that is how it needs to go. And CSA also recommends to use a pen test firm which has experience on the cloud provider, test multi-tenant applications, which is authorizing the tester as a tenant, and see if the isolation is working fine during the pen testing. Deployment pipeline security. It is the pipeline itself needs to be tightly secured and configured properly. Logs can track every code, infrastructure, and configuration and changes, tie them back to whoever submitted the change and whoever approved it. They will also include any testing results. Impact on the infrastructure as a code. Due to the virtual and software-defined nature of the cloud, it is often possible to define the entire environment using the template, and that are translated by the tools into the API calls that automatically builds the environment. If the system or environment is built automatically from the template, likely from CI/CD pipeline, then any change made in the production will be overwritten by the next code or the template change. Secure operations. So secure operations always should be built on top of, or we can say, should be built on these philosophy. Least privilege. People should have the access to the services or to the different workloads running in the cloud. This is on the least privilege. They should have access to whatever is sufficient to perform their duties. Application should be carefully treated. Of course, the application that we are deploying in the cloud should be treated carefully in the operations after the deployment in the production. Monitoring, keep on monitoring those applications, those services which are running in the cloud, so that any threat or any malicious activities, you can be notified and you can react to that. Cloud application design and architecture, segregation by default. This is something the application can easily be run in their own isolated cloud environment. Depending on the provider, this could be a separate virtual network or account, sub-account. Immutable infrastructure, as mentioned, this immutable infrastructure is becoming increasingly common in the cloud for operational reasons. Security can be extended, to achieve these benefits by disabling the remote logins to immutable servers, containers, adding files, integrity monitoring, and integrating immutable techniques into the incident recovery plans. Increased use of microservices. With this, it is easy to, or we can say it is much easier to achieve or to segregate out the different services on the different servers or the containers, since for one thing you no longer need to maximize the utilization of physical servers, and for another, auto scale groups can ensure the application scalability even when using the fleet of small computer nodes for the workloads. DevOps. So what are the benefits of the DevOps? It is number one, it is for the standardization. With DevOps, anything that goes into the production is created by the CI/CD pipeline on the approved code and configuration templates. Also, the development, testing, production are all based on the exact same source of files, which eliminates any deviation from the known good standards. Automated testing, as discussed, a wide variety of security testing can be integrated into the CI/CD pipeline, with the manual testing added as needed to the supplement. Immutable CI/CD pipeline can produce the master image for the virtual machines, containers, and infrastructure stacks very quickly and reliably. This enables the automated deployment and immutable infrastructure. Improved auditing and change management. You can easily trace back or track who accessed, or what was done, to at every level of information you can trace back. DevSecOps, or Sec DevOps, or Rugged DevOps. These are the different terminologies are interchangeably being used, but these terms are used when the security tools are integrated within the DevOps pipeline, and the security tools are performing the security testing and vulnerability management assessment as part of the CI/CD pipeline or as part of the DevOps. Okay, let's now review a few questions from this domain. What is the reason cloud computing affects the secure development lifecycle? So the keyword is SSDLC here. We need to look around this. There can be more than one correct answer in this question, but what is the reason, we need to find out within the SSDLC. So here the right answer is the shared responsibility model. In which step of the SSDLC process should threat modeling be applied? So we looked at definition. It is not the one which is performing the threat modeling. Design is of course the one which is which includes the threat modeling activity as part of the SSDLC. One form of the manual testing that might be very useful in cloud application development What is the keyword is manual testing here. So as we discussed in the cloud application development, we have DevOps or CI/CD, which is fully automated. But what is left as a manual testing? So it is the code review, which we discussed, and code review is the manual testing here. A security benefit of using the DevOps approach to application development in the cloud. The important point here is to review in terms of DevOps. Of course, it is not reducing the cost. It may or may not, because ultimately we will be spending much on the tools and the team which will be responsible to manage that infrastructure. Removing user inputs from the web. This is not the one, of course. Guaranteeing the approval of all the audits. Yes, partially, but may not be a good answer. A is a best answer for this question, standardizing the development testing operational environments. With this, we conclude the CCSK domain 10. Thanks for watching the full video. I hope you like the video. Please subscribe, like, comment, and share in your network so that others can also take benefit from it. Thank you.